Welcome back to the Electronics Inside, the show where we tear down tools, toys and appliances just to find out what's inside. I'm David and this is my flight data recorder, which you probably know as a black box. Or technically it's half a black box. We'll get into it. In terms of construction, it's a bit weird because you've got this back half which looks like it's got plates that lift off, but you've also got the front and back separated by this big, what's that, 3.5, 4 mil steel plate. So I feel like that's probably recording and that's data handling, maybe. So this has got to have a higher survivability than the back edge, which, since you've got the dent on that back edge, makes enough sense. So this flight data recorder comes from a Nimrod RAF aircraft. The Nimrods were based on the original jet airliner from just after the Second World War, the Comet, which you probably remember being famous for crashing a lot. When they couldn't work out the metal fatigue issue with the pointed cornered windows, they put one in a tank and then pressurised and depressurised the hull hundreds of times to simulate long hours of flight. They were upgraded and heavily modified into the Nimrod naval reconnaissance aircraft, which entered service in 1969, which is where this flight data recorder was used. However, this particular model wasn't introduced until 1989. So whether that means they didn't have data recorders before then, or they just had a completely different model, I don't know. I can't find the information. Based on the fact it's an MOD aircraft, that's probably for a good reason. So this unit was made by a company called the Plessey Company, which appears to have gone bust in 1989. So this flight data recorder was built just 2 years before the company went bust. So I don't know how much service and support the RAF would have received on these. And the aircraft that these were installed into, the Nimrods, were retired in 2011. So this is probably sat on a shelf somewhere gathering dust for the last 12, 13 years. The reason I'm being a little bit cagey about calling it a black box, I mean, firstly, because it's not black. And black would be a terrible choice in colour. You've got to find this amongst wreckage and fire and debris. So they make it nice and visible. Second of all, I've said it's only half a black box because this is the flight data recorder. It records the telemetry, the sort of data about the aircraft and the flight, the inputs received by the control systems, things like that. The other half is the cockpit voice recorder, which is recording the audio of what's going on in the cockpit, which gives an indication of what was going on and what the pilots were doing and how that may have been reacting, even if those inputs weren't being received and understood by the aircraft. It's like a backplane design. Everything's beautifully made. I don't know why that should be a surprise, and it smells old. So this sticker down here that says 8th of July 2010. So I guess this was the last time it was serviced and maintained, which is about 6 months before it was retired, or the aircraft was retired. Beautiful backplane. I wasn't expecting moving parts really at all, if I'm honest. I'm really surprised by that. See the damage this took, and I think that's probably just from dropping. I mean, it's mild steel. I think there's nothing hardened or anything about that. Nice solid plate, but this one's actually painted inside and outside. So on the rear, we've got this wonderful high density connector, and all of these are female pins. So the males were, because I imagine this with its little handles on front, probably slid into a rack, and you can sort of see some damage on the underside where I can imagine this was slid in and out of a rack, and those weld lines rubbed on the racking it slid into. And at the top at the front as well, you've got these sort of frangible links, so you could tell if somebody had unbolted that. And I think originally this would have had those similar kind of frangible links installed in the aircraft, so you couldn't rack this out, take the plane for a joyride. People have done it, look it up. So that's what I think this angle plate is. So we don't actually have to damage, or might not have to damage these frangible links, because if they're not holding anything onto this front plate, then we can leave that intact. So on the back, we've got this beautiful high density connector, and a nice warning sticker telling us it's 115 volts AC. Don't be tricked though. That is not 50 or 60 hertz. That's 400 hertz, which I can only assume is the frequency that an APU runs at. I don't want to get too into making assumptions yet. I kind of want to get it all out and released where we can see it all before I start getting things wrong. Okay, I know I said we shouldn't make assumptions, but based on the fact this model appears to be from 1987, what sort of data recording do you think is going to be on board? Do you think it's going to be EEPROM? Do you think it's going to be magnetic disc, magnetic tape? No, none of that sounds conducive to being in a bumpy, vibrating aircraft to me. EEPROMs, UV erasable ROMs, things like that seem too small, too limited. You'd need a huge array of them in 1987. Well, if you want to participate in the game, pause the video here, go over to the Element 14 community and write down what your bet is. Then we will see who's right. Oh wow, even bent the card holder. Is this connectorized at all? Can I separate the two halves? That would be nice. I mean, there are some connectors here and there, but not enough to make it useful. Onto whatever's in the front half. Now, interestingly, some of these screws on the front half, they're big posi screws, and there's significantly less of them, are actually stripped. It makes me think that this front half was definitely more regularly serviced, accessed, offloaded, maybe. Are these 1, 2, 3, 4, 5, 6 screws what are holding the... Yes. It's a hard drive. Wow. Okay. Hadn't seen that coming. Okay. All right, cool. Well, the bulk of this front half, which is the armoured half, can I call it that? You see is much thicker steel in construction. This is like 4 mil of hardened steel. Well, I don't know if it's hardened, but definitely toughened. It's different compound. I couldn't tell you what. But it's also lined with what I assume is some kind of intumescent heat resistant resin or polymer, which would resist burning and fire. And it's probably also slightly compressive to take the hit of an impact. That might be my favourite artifact from the electronics inside so far. The hard drive has got a physical hours count meter on it. So yeah, this will be taking all the discrete and data inputs from the aircraft. And now I look at this, this motor turns the platter on the hard drive. So it's like a remote motor, remote head control, because normally on the back of a hard drive you have power and one data bus, whether that's IDE, serial ATA, serially attached SCSI, and you'll have power. But I guess if you're trying critically just to save the platters inside this intumescent, fire-rated, highly damaged, dampened enclosure, then even moving the motor outside makes sense. And this motor must run the spindle through a series of pulleys and belts, as we can see here, which is weird enough. But also on the outside of this wheel, you can see it's actually perforated like the slots on a mouse wheel. So that must be like a light gate, and that's controlling the speed of the motor. So it's got a very finite RPM count, and there is a lot of notches on there, and that's not going to spin slowly. So the electronics on here must be controlling that incredibly fast. So even if I take that off, I'm still going to have data going through the firewall. I'm going to call this the firewall, like the bulkhead between the engine and the passenger compartment for a car. They call that the firewall. Engine bay, destructive, in a crash, written off. Passenger bay, the things you're trying to protect. I'm going to call that the firewall. Yeah, all the cables get disappearing through here are actually potted in. So I guess I'm taking this half apart first. First off, even with the damage, are these cards removable? Yes, they are, and They are beautiful. Right, I'm going to pull these out one by one and then we'll sort of examine them afterwards. It's interesting that the interface between the cards and the backboards appears to be a 2.54mm header. Those two cards also appear to be identical. Serial numbers are 2 apart, 10622 and 10624. Okay, these cards have got these additional copper posts, and if you look, they are at different distances, which means that you can't put a wrong card in the wrong slot. Great idea, they're keyed. Even the axial caps on here have got additional tie downs right the way around the board. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 cards. And apart from those first two, I think they're all very, very discreet. And they appear to be anyway. Even the hard drive controls are, well, I say hard drive controls, what I'm presuming for the moment to be hard drive controls are on little cards as well. Hard drive towards you, left hand side, card 1. This thing is so exquisitely made. Like every single one of the cores has got a heat shrink or a ferrule marking number on it. And although they've got the numbers written on them, they're also color coded. So even if you can't see the numbers, you can still work out what number it was from the color. Lovely on these tiny, tiny little cores. There is fairly traditional, albeit by normal standards, a large light gate. Wondering how to remove that motor, and actually those 4 holes in the pulley correspond with the screws. Nice touch. It actually now occurs to me that it's also a bit of a flywheel. It's got this perforated disc on it for speed measurement, rotation. So that will break and cover this light gate, and that will give it a pulse that will tell something in here exactly how fast that motor is spinning. When we've got this all apart, we'll try and trace out some of the cabling to work out how much of what is done where. Because at the moment, haven't got much of a clue. Ooh. Void if seal broken. Well, that was already broken. That's a shame, because this sticker has 23, big hole in it, 92. So I wonder if this hard drive unit came from 1992. What would you expect the capacity to be for a hard drive of that kind of age? Because if this model was from 1989, first of all, hard drives must have been expensive. By the mid-90s, a gigabyte was realistic. But in the 80s, hard drives, so expensive. Okay, I'll put that to one side. So those two 14-pin connectors actually are the hard drive connectors. Both these leads, which are disconnected here with the 14 pins, I think they were, have just run down that braided cable through the firewall and connected to the back of the hard drive. And this other penetration was for the belt drive. So these pins take a really, really low-level control of that hard drive. They are driving the heads, driving the platters, taking the read from the head back out. You could plug this drive in this format into another hard drive controller and read this off. You wouldn't need the 400 Hertz designed aircraft data acquisition handling controller. You could have another one at base that you could plug this into to retrieve data. That answers one question I had about data. There we go. That's the firewall freed up, finally. Inside this, what looks like a GRP, a glass reinforced plastic. I probably could disassemble this and see what material's inside, but I don't really want to. Bearing in mind this came from the 80s, one of the best fire-resistant materials was asbestos, and that wasn't banned until 2001. And even then, with MOD contracts, it's entirely possible that you were still allowed to use asbestos because it was frankly really good at its job. It's a little bit like halon. Halon as a fire suppression system, a gas fire suppression system, was basically turned into a war crime because it was like the best ozone depleting chemical ever invented. So you're not allowed to use it in commercial installations anymore. But if you're MOD or government, you can still use it. It's a bit weird. So definitely not taking that apart just in case it fills my house with asbestos. Yeah, I think I do need to take this off because it's actually a double stacked board and there's another connector on the side there. Whoa. Yeah, I think that was the right decision to undo that. Let's get this connector undone. And I think we're at a point of working things out. I love these connectors though, because the screws aren't just holding it once you've already made it. They're actually screwed all the way in and making the connection. So you've got this really positive connectivity there. Doesn't make me want to undo them evenly so I don't bend any pins though. Okay, I think at this point, I'm probably going to turn off the cameras for about an hour worth of Googling part numbers. So I'll see you on the other side.
1 hour later.
Okay, there's a handful of bits that are kind of obvious what they do and what they should do, which is nice, but actually the bulk of this is TTL, or transistor to transistor logic. Almost every IC on here is a logic gate, and it's part of the Motorola 14000 series, which is weird because paradoxically you can see exactly what each IC does, and a lot of them are just NAND gates in an array. And you could probe it very easily to work out what they do because there's no chips, there's no ROMs, there's no microcontrollers with code that you can't see. On the flip side of that, you would have to probe and work out every single one of these cards to be able to work out exactly what they're doing. But the bits I do know for sure, so the carriage on the left-hand side of the motor, we've got a bridge rectifier, we've got some linear voltage regulators, we've got some smoothing caps. It's all DC power conversion. And the transformers, one was providing power for the DC rectification, the other one was providing 70 volts at 400 hertz for the motor. Easy enough so far. Where I struggle is everything else. So this array that came off the back, so it's attached to this backboard. These are all transistor logic. They are mostly NAND gate arrays, but there's a couple of other different variations on logic gates in there. And on this side, we've got a handful of relays, but that's about it. That's about all I can tell you. Based on the wiring looms, it takes some in from the power, it takes some in from the connectors on the back, all through this connector, and the looms break out onto the cards. Not all that useful. On the individual boards, these first two, the two that are identical, seem to be using the logic gates more or less to be multiplexers. So these are taking a lot of raw data in. And I think these are the same, but they connect to different pins on the bus on the bottom. So they are doing the same job on different information, if that makes sense. So these are doing parallel duty. So there are a couple of boards that have these on, and these are demultiplexers. So they're taking some kind of encoded signal, presumably from elsewhere in the aircraft, and sending that back out as raw data that can be written to the storage medium. One cool feature that I wanted to point out on this board, it's got the demultiplexer again and a load of TTL logic gate based ICs. But it's got this really cool array on this side. And if you see on the front side, it's got a load of horizontal traces coming from different parts of the IC in the header. But on the back, it's got a load of vertical traces. And it's really cool because these little 0 ohm resistors are plugged in certain places to program the board. Can I say that? So you could move these pins around and change which trace matches where, presumably based on aircraft configuration, because they didn't make this just for the Nimrod. They would have sold this product to a lot of different aircraft. That would have changed how the signals were handled and which ICs they were passed to. And that's just a really, I don't think I've seen that anywhere else. It's almost like a semi-permanent patch panel kind of a configuration. Just really cool. Oh, and I have to say, I love these little fiberglass tapes holding the large components in place. That's just a lovely touch. Okay, so you may have noticed in that last few minutes of spiel, I referred to this as a data storage medium, not a hard drive. Because in that research, I also did a little bit of looking up to see how you would recover data from this. Now, there was a 19-inch rack standard accessory that you seem to have plugged this into to recover data. And it's interesting that it listed the PV1584 by part number, but also said all your tape-based data recorders. So I said this was a hard drive. Is it? Or is it a continuous loop of tape, like a giant 8-track? I have thoughts on this. First of all, I don't suppose we're ever going to find a functioning way of getting data off of this. Second of all, if we did, we have no idea what proprietary formats that would be stored in. And third of all, if we did, I don't suppose the data is going to mean anything to us. It's just going to be a set of numbers and digits which are stored in some kind of industry standard way. Lastly, even if we could get all the data off it and we could understand it, I'm not sure the MOD would really appreciate that. So I'm edging towards the idea of seeing what's inside. Yeah, let's do it. Oh, and the warranty was already void. We found the sticker. It is tape. It's a continuous loop of tape. No, it's reel-to-reel tape. Oh, wow. Oh, that's seriously cool. So that sound that I'd mistaken for platters is actually the zinc or alley spools. So the tape feeds off of, well, I don't know which way this goes, but I'll assume it's going this way. So it comes off that top roll, around here, past 4 heads, and then back this way. And I would assume, depending on which way this tape is feeding at any given time, that you're actually going to have erase heads and read write, something like that to validate the data being written to the tape. Well, that's super cool. Well, there is the insides of a late 80s flight data recorder. Yeah, virtually none of that is as I expected. I shouldn't have been, but I think I have been surprised by the build quality. You would expect it to be good given the application. Stunned that it's all TTL. I really hadn't expected that, but I guess given the time when this was implemented, code and software wasn't really trusted in the same way, whereas TTL had at least been around and been proven and couldn't fail in the same way. And at the very least was quickly replaceable. You pop out a card, replace it with a like for like. You didn't need to flash any software, do any updates. It would just start working again. And the use of tape-based medium, it's really funny how quickly I assumed this was a hard drive based on its physical size and form factor. And I do wonder how much applications like this may have influenced hard drive design. I mean, even with it open, at a cursory glance, I could forgive someone for thinking it was a hard drive. Well, I hope you've enjoyed it, and if you've got an idea for a teardown you'd like to see, don't forget to head over to the Element 14 community, let me know, and if you have any questions, that's the best place to reach me. Thank you so much for watching. I'll see you next time.